Alright, so in this video, I'm going to talk about zeros a little bit and what they mean. Because it's important to be able to understand before we get to solving like why we need to know what zeros are. So think about it this way. A zero or a root or a solution, these all are x-intercepts. It's the value of a function when it's what x equals when y is 0. And these are real. These are real solutions. Real zeros, real roots, real solutions. If it crosses the x-axis, it's a real solution. So if you have a graph, and I don't even know, I'm just making this graph up, it would have 1, 2, 3, 4, 5 real solutions because it crosses the graph 5 times. Now, it may have more, we don't know. Now, we could use some of our other clues like end behavior and turning points to figure out what the degree of this polynomial likely would be, but for now we're just focusing on zeros. And so in a previous video or in previous lessons we learned how to factor, and there are 3 situations that'll happen called multiplicities that we'll focus on. If the same factor occurs just once, so let's say you have like just x plus 2, that factor. That means you have a multiplicity of 1. That means it's going to cross the x-axis. If you have a factor show up twice, like let's say we have x minus 1 squared, that has a multiplicity of 2. That means it's just going to touch the x-axis. So using a graph over here as a reference, let me get the graph drawn again. If I have a multiplicity of 1, it's actually going to physically cross the x-axis. If I have a multiplicity of 2, it's actually going to touch the x-axis. So it's still technically a 0 because it's touching that point on the x-axis, but it's not actually going to cross. It acts more like a quadratic, whereas multiplicity 1 acts more like a line. Then there's a third. And that's if we were so lucky as to have the same factor 3 times. That means it has a multiplicity of 3. And it's going to do something called slide across the x-axis. And so it might go like this, like a little slithery S. It crosses, it touches, it's kind of the same, it slides across that x-axis. And so with those 3 things in mind, it's going to tell us a lot about problems when we're trying to find solutions. Because any polynomial you have, let's say x to the 8th, has to have, and it can be like x to the 8th plus blah, 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 on and on until whatever, plus 1. It has to have it has to have exactly 8 solutions. Now that could be composed of like some real, some imaginary. We don't know. We just know that the total has to be 8. And so if I plug this big long equation into the calculator and it does something like this, and I'm totally making this up, but let's say the graph looks something like this, and then it touches, and then it comes back up, and then it crosses, and then it slides past. I don't know if it would ever slide past in this kind of function, but just for the sake of arguing here, let's look at the zeros. Well, it touches here. That means it has 2 zeros. It crosses here, meaning it has 1 0 there. It slides here, meaning it has 3 zeros there. And so all in all, that's 3, 4, 5, that's 6 zeros. Well, I need 8, so that means 2 of them are going to be imaginary. And so the reason this is helpful is we can start to factor and use polynomial division and put us in a situation where we can actually find what those imaginary solutions would be. And so it's important to know that the reason that we're factoring are that we can find where it crosses the x-axis, because in order for it to be a factor, that means you have to be able to set it equal to 0 and find where it crosses the x-axis. Imaginary numbers aren't factors. They're solutions, they're imaginary solutions, they're important, but they're not considered factors. And so why all this is important is I can take something very simple like x squared plus 3x plus 2. And I factor that, x plus 2 and x plus 1. and I'm going to set that equal to 0 so I can solve. Well, this factor has a multiplicity of 1. This factor has a multiplicity of 1. So that means on my graph, at x equals -2, my graph will cross. And if I look at end behavior, it's positive, so the right side ends up, and it's an even, so the left side obeys the right side. If you need help with that, find my video on even and odd functions. It's going to cross at 2, or at -2, because it's a multiplicity of 1, and it's going to cross at -1. So I know it must turn somewhere in here. And so we can start composing these sketches of graphs based on their zeros and end behavior and turning points and all of these types of things. And that's what makes it fascinating. So I'm going to combine the factoring that we've done in the last video or in previous class with our new zero theory on a pretty complex problem. If you're in my class, this is number 60 on page 302. And this is a pretty good problem because we've got to use all those factoring skills that we learned along with our multiplicities to find out the types of real and imaginary and whatever solutions we may have. So let's go ahead and get started. The problem is this: x to the 5th plus x cubed plus 2x equals 2x to the 4th plus x squared plus 1. And so what I always like to do when I have a big long polynomial like this is I like to put it in standard form. So I need to subtract 2x to the 4th, subtract x squared, and subtract 1 from each side. And so that gives me this big long polynomial. And I'm going to go ahead and put it in standard form. So minus 2x to the 4th plus x cubed minus x squared plus 2x minus 1 equals 0. It's in standard form. It's in biggest exponent down to smallest exponent. And so now I have 6 terms. And so I need to start thinking back to the factoring video and looking for important things like, remember, we could divide it into 4 terms and 2 terms and see if there are any, difference of squares, sum of cubes, or difference of cubes. It doesn't look like these 2 terms over here or anything like that. And so you can start playing around with combinations. What I'll see is I notice I have a quadratic here, a pretty standard 3-term quadratic trinomial, and those I know how to factor and use quadratic formula and stuff to solve. So I'm going to do that. I'm going to focus on this green expression here, which would then leave me with this purple expression over here. And now I look, well, this purple expression, they have a GCF. I mean, they all have x cubed. So I'm going to go ahead and pull x cubed out of there. And that leaves me with x squared minus 2x plus 1. And, well, dang, if you notice over here, I could pull out a -1 here. Look at this. If I pull out a -1 to make this easier to factor, oh, wow. Look at that. These end up being the same. Man, all I did was manipulate it a little bit, and now this big whole long term here, I'll represent in orange, this big long polynomial has a greatest common factor of x squared minus 2x plus 1. So if I pull that out, I'm left with x cubed minus 1. Now things are going to start getting interesting. So I'm going to move on to the next slide with this bit of information right here. X squared minus 2x plus 1, make that a little neater, and x cubed minus 1. Yeah, that's what I have, equals 0. So now I notice something interesting. This is a quadratic trinomial that I know to factor. What multiplies to give me positive 1 and adds to give me -2? X minus 1, x minus 1. because negative 1x and negative 1x make negative 2x, and negative 1 times negative 1 is positive 1. Sweet. This is two terms, 1, 2, and it's a difference of cubes. So if you remember from the factoring video, that'll make this x minus 1 and x squared plus x plus 1 squared, which is 1, equals 0. Look at this. I have 3 of the same factor. 1, 2, 3. So really, I could rewrite this as x minus 1 cubed times x squared plus x plus 1 equals 0. And so really, this factor right here, this x minus 1 cubed, that means it has a multiplicity of 3. And so if I set that equal to 0, x minus 1 equals 0, I get x equals 1. I know that my graph is going to slide across the x-axis at 1. And it accounts for 3 zeros. So if you remember, our polynomial originally had a degree of 5. So we're looking for 5 zeros. And I've already found 3 of them, because that has a multiplicity of 3. So really, I only need 2 more zeros. And I don't know if they're real or imaginary. So let's look at this right here. Is there anything that multiplies to give you 1 and adds to give you 1? No. So I'm going to have to use quadratic formula or completing the square or something like this. I'm just going to go ahead and use quadratic formula. X equals negative 1 plus or minus 1 squared minus 4 times A times C, all over 2 times A. And so if I simplify this, I get x equals negative 1. Let's get that x out of there. We'll just say negative 1 plus or minus the square root of, well, 1 squared is 1, and 4 times 1 times 1 is 4. 1 minus 4 is negative 3 over 2 times 1 is 2. Well, if you remember, when we have negative numbers, now I know that I'm going to have 2 imaginary solutions. Let's simplify. Square root of negative 3 becomes I square root of 3 over 2. And so my 3 solutions are x equals 1, and that happens 3 times. X equals 1, x equals 1, x equals 1, meaning it's going to slide. And I have these 2 imaginary solutions, negative 1 plus I square root of 3 and negative 1 minus I square root of 3. So there's where my 5 solutions come along. And so I can sketch a rough portrait of this graph based off what we know. It was a positive x to the 5th. So I know the left end behavior is down and the right end behavior is up. And I know at positive 1, my graph is going to slide. So I'm just going to make it slide. And that's it, because that accounts for 3. The other 2 are imaginary. So I bet you. Oh, and if we look, let's go back. I know it crosses the y-axis at 1. That's my y-intercept. So let's go ahead and put that on there. Oh, I'm sorry. It crosses right here at negative 1. So let's go ahead and add that to our information. And it looks like I kind of already did. Right here's negative 1. So I bet you quite a bit of money that if you put our original function that we had, x to the 5th minus 2x to the 4th plus x cubed minus x squared minus 1 into the y equals of your calculator and hit graph, I bet you it looked something like that. All right, that's a little longer than I wanted it to be, but hopefully you can see why all this is important. And if you have any questions, send me a comment. Thank you.